So here in example A, part A, we're going to use the fundamental theorem of calculus. So one of the things that I recommend doing is finding the antiderivative function, okay? Don't plug in any numbers yet, as if it were an indefinite integral. 3x squared, we're gonna add 1 to the exponent. When we divide by that new exponent, we just get a 1 there in front. You can write it if you want to. 3 divided by 3 is 1. With a negative 6x, we're going to add 1 to the exponent and then divide by that exponent. It gives us a 3. And just the 5 is going to give us 5x. Now, just for argument's sake, I'm going to add that plus c here that we were used to. And I'm going to write a little note. This guy here is irrelevant. Not sure I even spelled that right. Irrelevant, maybe with an A? I don't know. Anyway, and I'll show you why here in a minute. Basically, when we subtract the two, they're both going to add to 0 anyway. But we'll put it on this first one just to show. Now, one of the things, once you've found that antiderivative function, you need to tell yourself and your reader that you still have to evaluate it from -2 to 4. Again, that's what that big line says at the end. What we're going to do is we're going to plug in 4 into that function and then subtract that same function where we plug in a -2. And we're going to get an actual numerical value. Well, the f of 4, you would have 4 cubed minus 3 times 4 squared plus 5 times 4. We'll go ahead and put that plus c just so you can see for yourself what happens to it. Minus, and now we're going to plug in that -2 everywhere. So we have the -2 cubed minus 3 times the -2 squared plus 5 times the -2 plus c. Watch your signs again with everything that you do. So if we combine all of the numbers there on the left, we would end up with, I believe, a 36 plus c on the left. And then on the right-hand side, if we do the same thing, focus here, again, watch your parentheses and those negatives. That's where a lot of people are losing some points. That would give us a -30, and again, we have a plus c. Notice what happens when we're subtracting. We're going to subtract that -30, subtract that plus c, so we're going to change signs here. So that gives us a 36 plus c plus 30 minus c. So that's why I said the c's are arbitrary. It doesn't matter what that constant could have been in your antiderivative function, because when you do the fundamental theorem of calculus, those constants will always add up to 0. And so in this case, we are left with the number 66. So let's try part B. Same thing here. We're going to have to find the antiderivative function first. So we may need to use u substitution here. Maybe not. Maybe you guys kind of already get it, but that's okay. We are going to let u be x minus 4, which means du is just dx. So this will give us the integral from 1 to 5 of 1 over u du. And remember, the antiderivative of that is the natural log of the absolute value of that denominator. So now we can plug back in what u represented. U was an x minus 4. Be sure you plug that back in before you evaluate it between 1 and 5. Because remember, that 1 and 5 are the lower limits of integration with respect to x. So you need it back in x before you evaluate. If we plug in the upper limit of 5, we get the natural log of the absolute value of 5 minus 4 minus the natural log of the absolute value of 1 minus 4. So that's the natural log of 1 minus the natural log. That gives us a -3, but remember, it's an absolute value, so that would be the natural log of a +3. So we can write this as the natural log of 1/3 or a negative natural log of 3. They're both the same. So I can actually show you two different ways to get the same answer here. Remember, the natural log of 1 is 0. So we get 0 minus the natural log of 3. That's the same thing as the natural log of 3 to the -1, because remember, that's an understood 1 there. We can treat that as an exponent and move it back. So that would give us the natural log of 1/3. Here's the or. You can treat that negative there. Remember when we're doing the expanding and condensing of natural logs, subtraction means division. So we can just go straight to the 1 divided by 3. Both valid, both work.